excuse me, it's the same thing on this table, except that your degrees of freedom is 2. Yeah, it's 2. Which hopefully that makes sense. Your 3 rows minus 1 is 2, and your 2 columns minus 1 is 1. 2 times 1 is 2. So do that. It looks like your alpha is 0.05, so that's the proportion in the tail. And then that'll be your X, or your chi critical. Yay! And then you either reject or fail to reject, depending on if your chi is greater than or less than your critical. Alright, so Cramer's V, or Cramer's V, is, it's a formula. It's another square root of something. One second, let me find it. Alright, so Cramer's V is the square root of chi squared over n times degrees of freedom. So, hopefully, you get an answer that is all 3 decimals. Unless I did it wrong, in which case you're great, and I'm wrong. But, yep, so you do that. And then that is all the calculating you have to do. And then we get to these little paragraphs, which are a little confusing. But, yeah, okay, so when you go, participants who were asked about the speed when the cars smashed into each other were, you're gonna, if it's significant, basically you're basically gonna have to interpret the information that you find. If it's significant, then there was a difference. And just make sure that you read the problem to answer this first paragraph, because I can't really explain it without telling you the answers. You can always Facebook me and just like, hey, did I get this right? That's fine with me, and I'll let you know. The second one is a little bit different. So if it is significant, then the test would indicate it, and if it isn't, it wouldn't indicate it. That the question did have a significant effect, or didn't, depending on if it was significant or not. And then what you want to do is you want to say your chi squared and give your degrees of freedom and your n, which is what I gave. I'm pretty sure that's what you do. I'm not entirely sure. I'll ask Coke, and then if you still want to know, I will tell you. And then you're going to give your eta squared value, or your chi squared value, and then you're going to say that, the probability is less than whatever your critical value was, because, or greater than, depending on if it's significant, though by now you've probably figured out what it's supposed to be. And then you should probably give your Cramer's V score, because that's the only one you calculated. So yeah, hopefully that made sense. Yeah. So then problem 4. Yeah, problem 4. Is again basically the same thing. You have another table, calculate. So again, to find the F expected of women who thought somewhat thin, you would have to do 40 times 80 divided by 140. So yeah, then you find your expected, and then you're gonna do 29 minus your F expected divided by your F expected to find your chi-squared term. Oh, yeah, square it. Always square the top. And then, calculate all of those, add them all up together, and you're going to get your chi-squared. Also, to find chi-critical again, you just go to the table, you put in the right degrees of freedom, which hopefully you'll figure this one out, because I've told you the last two. Oops! And then, if it's bigger, you reject, and if it's smaller, you fail to reject, and then they want you to calculate your phi efficient, or your phi coefficient, which, in case you've forgotten, is the square root of chi squared over, the square root of chi over capital N. I think. Oh, whoops! Square root square root of chi squared over n. Ha 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 ha. I forgot to do that. That's okay. Hopefully you do that and you get a bigger one than I got, because all of mine are like not very big. Which I mean, like, they're not gonna be like a whole bunch bigger, but they'll be a little bit bigger. Okay, so the number 5. Same thing. You don't have the table this time, but I would suggest making a table just so that you can keep all of the information in your head. So basically, volunteer high, you would do 156 times 53 divided by 208, and that'll equal your expected. And then once you calculate your expected, it's observed minus expected squared over expected, all of them added together, and then that'll be your eta squared. And then your eta chi, your chi squared. And then to calculate the critical point, you have to go back to the table in the book, Appendix B, find that out. And this time they want a 0.01 significance. So yep. Alright, so that's the homework. It doesn't, I didn't have to explain it a whole lot, but it took me a while, just because it's a lot of calculating. So, good luck!